So in this first experiment, what we're going to do, among other things, is to introduce you to a few of the pieces of equipment that we'll be using throughout the semester to make measurements. So we'll be teaching you how to actually interpret what you see on a measuring device in order to make proper measurements. So one of the more common types of equipment that we'll see in the laboratory is to measure out liquids or solutions. And we call these volumetric glassware. So for example, on the left side here, we have our beakers, and we have a 250 milliliter beaker, we have a 150 ml, and we have a 50 ml beaker here. So you'll notice that they all have a very distinctive shape. In the middle here, we have an Erlenmeyer flask, and this is a 125 milliliter Erlenmeyer flask, and it has a shape that is also very distinctive. And on the right side, we have three different sizes of what are known as graduated cylinders. All right, so we have a 50 milliliter graduated cylinder. We have something slightly smaller. This is a 25 milliliter graduated cylinder. And then we have one even smaller than that. We have a 10 milliliter graduated cylinder. So we're going to decide, we're going to choose which device to use depending on how accurate we need to be with our measurements. So we'll take a look at each of these devices in detail. You'll see a picture of each of them that will show you what the smallest graduation mark is, or the smallest tick mark is between the different readings. So for example, in this 50 milliliter beaker, you'll notice here that the tick marks go up by every 10 milliliters. And this is going to vary between each of the instruments. So that's the first thing that you're going to have to look at when you take a look at the different still shots of the pieces of equipment. And then the second thing that you'll be able to do is to estimate how you can actually read that device based on what those smallest graduation marks actually are. Okay, so now that you've taken a look at each of the different volumetric pieces of equipment, we're going to take a look at now at how we read the volumes. So I have here some deionized water, and what I'm going to do is add some to a 50 milliliter graduated cylinder. And when you add a liquid to anything that's cylindrical, when you add a liquid like water, for instance, to something that's cylindrical, what you will notice is that that liquid forms a very characteristic shape. Down here at the bottom, it looks like a little smiley face. That represents the meniscus. And the way that you read that meniscus for water is you always want to read the bottom of where that meniscus is. You need to set your device on a flat surface, and then you get yourself, so you may need to stoop a little bit, you want to get yourself so that the bottom of the meniscus is at eye level. So that's what you're going to read for the volume, and then you're then going to make your measurement based on what the smallest increment or the smallest tick mark is on your measuring device. So for example, in this 50 milliliter graduated cylinder, all right, you'll notice here when you looked at your picture that the smallest graduation mark is 1 milliliter. So it goes up. This is 40, for instance. This is 41, 42, 43, 44, 45, all the way up to 50. So my smallest tick mark here is 1 milliliter, which means I can estimate now to somewhere between that 1 milliliter mark. So if I look at my volume, if I were to set this on something flat and I get my meniscus at eye level, I can see that it's between 10 and 11 milliliters. So that means it's more than 10. We know for a fact that it's more than 10 milliliters, but it's less than 11. So it's 10 point something. And that point something is what you get to estimate as the person making this measurement, right? That last digit that you estimate is going to be uncertain, and every single measurement is going to have some degree of uncertainty in it that is dictated by your measuring device. So for example, if this bottom of the meniscus is exactly between 10 and 11, I can say that it is 10.5 milliliters. whereas somebody else may think that it's 10.4 or maybe 10.6 milliliters. So that last digit then, and you'll see that being represented in the uncertainty, it's plus or minus, and in this case it's plus or minus 0.1 milliliter, based on the fact that our smallest increment or tick mark here is 1 milliliter. Now we can contrast that to a slightly different measuring device. So if I take my 50 milliliter beaker, for example, right, what you'll notice, and you saw in the picture of the 50 milliliter beaker, is that the smallest increment here, the smallest tick mark is 10. So it goes from 10 to 20 to 30 to 40. So reasonably, what can I estimate that volume to be? If my meniscus, for example, is between 20 and 30, can I reasonably estimate that to be 22.5? Well, you cannot, because you don't have those really small graduation marks, right? Here your smallest graduation mark is actually 10 milliliter, so reasonably you can estimate to maybe plus or minus 1 milliliter. All right, so we can say this is maybe 22 milliliters. Somebody else looking at it may think it's 21 milliliters, right? So the uncertainty here in the last digit is plus or minus 1 milliliter. So that uncertainty is going to be dictated by the device, and specifically by that smallest increment or tick mark that you see. And it's really important that you don't misrepresent the accuracy of your instrument, right? So you really want to pay attention to what those smallest increments are. So another very common device that we're going to be using in the laboratory to make some measurements is a device used to measure masses, and that's called a balance. And we have here a balance that's shown to you. And this is an electronic device, so this is going to make the measurement for you, but just like with any other measurement, there is some uncertainty built into it, and that uncertainty is always going to be in this last digit here. So in this particular balance, we go to the 100th place. So our uncertainty would be plus or minus 0.01 grams whenever you make a measurement using this particular balance. Before you use the balance, before you place anything on the balance, you want to make sure that you zero or tear it so you get everything to zeros, so you can hit that button. And then to place something on the balance, you can lift the lid up, and then you can place your object on the balance. Now it's really important that you don't, or that you try as much as possible to place a receptacle on the balance. You zero it, and then you can place your materials into that receptacle so that we don't inadvertently damage the surface of the balance, and then also the inner workings of the balance as well. Okay, so now that we have an idea of the different pieces of equipment that we're going to be using, let's go ahead and make some measurements. So the first thing I'm going to do is to take a 150 milliliter beaker, and I'm going to get the mass of this. I'm going to zero my balance, or tare it, T-A-R-E, open the lid, and I'm going to place my 150 ml beaker on the surface, and I can record my mass of that empty beaker, and I can see that it's 66.29 grams. I'm going to remove my 150 ml beaker, and then I'm going to add to it now 50 milliliters. I'm going to try to add as accurately as possible 50 milliliters of the deionized water. So notice I took the beaker off the balance when I'm adding my 50 milliliters. You don't want to add it directly on the balance in case you spill some water. You can mess up the electronics in the balance itself. Alright, so we're going to add in here our 50 milliliters of deionized water, and again you want to make sure that you get that meniscus to eye level to make that measurement. Okay, so I have my 50 milliliters in here. I'm going to reweigh this again on the same balance that I used previously, and I'm going to record the mass of the beaker now with the 50 milliliters of deionized water in it, and I can see that it's 111.56 grams. So I'm going to repeat that process with an Erlenmeyer flask, a 125 milliliter Erlenmeyer flask. I'm going to get the mass of it empty and record that. I'm going to then add 50 milliliters of water and get the mass of it with the 50 mils of water in it as well. So the mass of our empty Erlenmeyer flask here is 81.68 grams. And then I'm going to remove that from the balance and then add 50 milliliters of deionized water to it. Okay, so I've added my 50 mils of deionized water, place it back on the same balance, and I record the mass here. So that's 122.61 grams. And I'm going to do this a third time now using a 50 milliliter graduated cylinder. So there's my empty 50 milliliter graduated cylinder. I zero my balance and I place it on and I record the mass, so 76.37 grams. I'm going to remove it and then add 50 milliliters of DI water to it. Okay, so there's my 50 milliliters of deionized water. Place it back on the balance and I record the mass at the end, and I see that it's 126.26 grams. And for each of those devices, what I can do is subtract the initial volume, which was just the empty device, from the initial mass, which was just the empty device, from the mass of the device plus the 50 milliliters of water, to actually determine the mass of the water that is in each of those devices.